Hello friends, so this video I am going to talk about the course review of heat transfer course. So in earlier I had taken two another videos also, and the just previous video was related to applied thermal sciences or applied thermodynamics to be correct. So this is the next video is about heat transfer course review, and it is mostly a continuation of the previous one. So it's better if you first look at the course review of applied thermodynamics and then come back to heat transfer course review. So let's start with the outline of for this video. So I'm going to mostly cover the major topics which are covered in this course, some of the study resources which I use, not to mention the major resources because there are multiple resources coming up now. Then the evaluation scheme and some related fields to the field of heat transfer. So let's jump into the major topics. So usually the heat transfer is called as HT, abbreviated as HT, and the more specific field or more broader field to be correct is heat and mass transfer, where we not only talked about the heat transfer, but we also take into consideration the mass transfer part of the thing. So it's only a small addition to heat transfer concepts. The mass transfer is very similar. The equations will be very similar. So if you have understood the equations of heat transfer, the mass transfer thing are very easy. So if you miss the mass transfer, it's okay. Then heat transfer is one of the best base for applied thermal sciences. So if you understand this heat transfer course very well, if you have all the clarity, you will have grip, very well grip on applied thermal science domain. So I would also recommend you just look at the domain video, which is where I'm explaining the various domains, the three major domains of mechanical engineering. So you will get an overall picture of what the three major domains are and where heat transfer lies, what are the related fields, etc. And mostly the heat transfer course is numerical based course. So obviously it will involve the basics, concepts and theory, but it will not limit yourself you to the theory. The exams will hardly have any theory questions. It will mostly be numerical based, though the numericals will be easy if you have clarity. Then the next thing is the numericals can sometimes be very complex, and that represents a situation which is a practical in nature. So this could have interested you if you have done or solved some questions, or the questions which are at the end of some textbooks may interest you and may give you some more thoughts about where this course and where the concepts could be applicable. Then so the course overall is an easy course. Just there are so many formulas, but that's okay. You will have you can easily remember the formulas, or you will be provided with the formula sheet during the exam. But since there are a lot of formulas and generally the formulas are provided in the exam, you should have the clarity that which formula is applicable in which situation, because it will confuse you at the end that in a situation you may think that multiple or all the formulas are applicable, but only a few or only one formula will be applicable. So you should have the clarity that which formula is applicable in which situation. Then are there any prerequisites? So yes, I would say there are some prerequisites, because since this is a massive course, sir will not start from the basics. He'll start directly from the energy, heat, and go into the heat transfer modes. So you should have some basic clarity about the chemistry, the properties of liquid related to the thermodynamics, and you should have hands and grip on applied thermodynamics course, if not the basic thermodynamics. Then the major topic. So it is a very classified course, and you should have a very good clarity, because sir is an excellent professor. Usually this is taught by Pilas Tilak sir or Nilesh Pawar. Both are excellent professors. I have studied from Pilas Tilak, and he teaches in a very classified way so that everything gets clear and fits and studies by level. So you'll start with energy, then heat, then go to the next level, then the next topic. So all the topics are related. So you should have all that will help you to remember things. So first you will have the basic definitions of heat, energy, classify energy. And I'm also making have some videos and the complete playlist of this course of heat transfer. So you will have an advantage learning from my videos also, and the complete notes are also available. Then the only things you need to understand or study in this course is the three modes of heat transfer, which are namely conduction, convection, and radiation. So with these three modes of heat transfer, you should understand the physical process. What is the actual physical process at the molecular level, which happens, which leads to conduction or convection or radiation. Then there will be some formula which will be based on some laws. So it may be Fourier's law or Newton's law, Stefan's Boltzmann law. These are the three laws which will guide conduction, convection, radiation, respectively. So you should remember the law and the formula. Then there will be some derivation. So if there is a fluid movement, there are multiple dimensions involved. So sir will derive some formulas, or sir will derive some big equations. Obviously, you need to understand what the different terms are. So in any differential equation or any a big equation which you derive, or an expression which you derive, which solves for some temperature, heat value, coordinates, etc., time, energy, anything it can be, you should understand what an individual term represents in physically. So if a term can represent that there is an energy change, a term can represent that there is a movement in XYZ coordinates, a term can represent that this is a change in time, etc. So you should just remember that if there is no change in time, some terms will obviously disappear. So you should classify and understand the equations in such a way that it becomes easier to recall, and this will be definitely asked in interviews. He will not ask to solve problems, he'll ask what a specific term is representing in an equation. Then obviously the main part is the numericals, which you need to solve and practice, get hands on grip. So the one important thing you should remember is you should have clarity with the units of energy and rate of heat transfer. So that is absolutely required. Then some of the resources. So lectures are beautifully arranged, and that will definitely help you to grasp all the concepts very beautifully. So because this is a somewhat complex topic, or a course, a professor's help is required, and textbook may not be suffice to understand all the concepts. Then obviously textbook is useful to get some theory clear, derivations clear, and practice questions. So I'm enforcing on practicing questions because that is the main part which we will ask in exams. There are very long questions which are capable. So it may ask you that something is happening, then the second process is happening, then the third process is happening. So if you get your numerical wrong or some calculation wrong in the first part itself, then the whole answer will be wrong. So you should better have good calculation accuracy, and have good hands on your calculator also. Then I had some other references also, such as notes of Gate, and some online textbooks which I got. So those were helpful to get different perspectives of this physical process which I was mentioning. So these different physical processes, so different authors have explained the things differently, the formulas, derivations, the implications of the derivations, the inferences, conclusions. So there are multiple conclusions, and a single textbook may not be enough. So it's better you go online and take out notes, take out different textbooks and read up theory, so you have better clarity. And then when you have better clarity, your mind opens up to different applications of the same concept. So that's how you can figure out what's your interest lies in. Then for the evaluation scheme, sir may give you some assignment, or majorly there will be quiz. It would usually be closed book, but the formulas will be very easy to remember or recall. And midterm and comprehensive exams will heavily have questions which are numerical based. Okay. And as I said earlier about the professors, so they are very good. You can ask any type of doubts repeatedly, and they'll explain, and they'll try to explain in different ways also. So you have all the type of understanding required. About the field, so it is, as I said, it is applicable to or related to applied thermal science, and it is the base of applied thermal science actually. Then a very broad field, an important field coming up in next years to see is heating, ventilation, air conditioning, and refrigeration. So this is heating, H heating, V is for ventilation, A and C is for air conditioning, and R is for refrigeration. So HVAC, or sometimes it is called as HVAC and R, is a very broad field. There are a lot of research possibilities, and it is worth exploring this field. Then we have concept of sustainability coming, green energy coming, renewable energy coming. So there are also a lot of applications in those fields. So heat transfer has endless applications. And I am also interested in heat transfer in thermal science. So if you have any queries, you can come up in comment, and I'll be happy to talk to you about more possibilities and more experience, etc. And about the fields related or the courses related to this course. So coming up in other semesters, you will have prime movers and fluid machines, which is having a base of heat transfer to take. So if you have heat transfer, if you have liked heat transfer and found it interesting, you will definitely find PMFM interesting. Then we have another course of engine, motors, and mobility that is also very much related to heat transfer, or concepts of heat transfer are required in engines and motors part at least. Then there are some disciplinary electives available of our department. So if you have liked and enjoyed studying heat transfer or applied thermodynamics and PMFM, if you have already studied, then the courses which are listed, which is RAC, refrigeration and air conditioning, power plant engineering, PP, CFD is computational fluid dynamics, and partly introduction to MEMS. These four fields may interest you. Then you can also take numerical analysis, where the numerical part of heat transfer equations to be solved numerically there, that is explained. So these are the fields. If you have any queries, please comment, and the handout will be available in the description soon. Thank you.